So on this page here, I've written out a little bit more succinctly the probabilities that we just found in that last example. So I have here listed each of the superheroes in the superhero basket and the probability of finding each one. And here, probability is just represented by a p. You could also say p of x. So it's the probability of finding the superhero listed here. So we're going to start with the first rule that I mentioned, which is the converse rule. And the converse rule tells you the probability that an outcome will not occur. So we're going to write it like this. We're going to say the probability of getting not x. And we find the probability of getting not x, so the probability that some outcome will not occur, by subtracting the probability of x from 1. So the probability that x will not occur is equal to 1 minus the probability of x. And we can do an example here. So I'll just start at the top here with Hulk. We're going to say the probability of getting not Hulk is going to be equal to 1 minus the probability of getting Hulk. So we're saying the probability of not x is equal to 1 minus the probability of x. That means that the probability that I'm going to reach in here and pick up somebody who's not a Hulk, so like that, we're going to find that probability using this equation. So our probability of not Hulk is going to be equal to 1 minus 0.18, which is our probability of getting the Hulk, and that's going to come out to 0.82. So we have a probability of 0.82, or an 82% chance that when you reach into the superhero basket, you're not going to pull out a Hulk. All right, so that's the converse rule. We're going to move on to the addition rule next. And what the addition rule tells you is the probability of having one outcome or another outcome. So again, we're still talking about one event, that's one draw out of the superhero basket, and we want to know the probability of getting one outcome or a different outcome. So I'll say the probability of x or y, just keep this consistent in terms of lettering, we'll say that, and we're going to get that by adding together the probabilities for our two different outcomes. So the probability of getting x or y as an outcome is going to be equal to the probability of x plus the probability of y. So going through an example here, let's say we want to find the probability of getting Iron Man or Black Widow. And I'm going to just use their initials here, so probability of Iron Man or Black Widow. So if I want to find this probability, I'm going to plug their probabilities into this equation. So in order to find the probability that when I reach in here, I'm going to get either an Iron Man or a Black Widow, which, oh, I didn't. The probability of getting Iron Man or Black Widow is going to be equal to the probability of getting Iron Man plus the probability of getting Black Widow. We can plug in our numbers here. Our probability of getting Iron Man is 0.14. Our probability of getting Black Widow is 0.23. So our probability of getting Iron Man or Black Widow is going to come out to 0.37. Or a 37% chance. And by the way, I'm doing this math in my head, so if you see any mistakes, again, let me know for extra credit. But I think I'm okay there. All right, so we have our converse rule and our addition rule now. The final rule that we can use to calculate probabilities is going to be called the multiplication rule. And the multiplication rule is different because, unlike the first two, we're now talking about the outcomes of multiple events. So what's the chances that you're going to get one outcome in one event and then another outcome in another event? What's the chances that you're going to get one outcome and then another outcome and also another outcome? So for your multiplication rule here, we're going to be finding the probability of getting x and y as outcomes across two different events. And we're going to do this by multiplying the probability of x times the probability of y. So let's say we want to find the probability that we're going to get a hawkeye and then a falcon. So we're going to say, what's the probability of getting hawkeye and falcon? And again, I'm just abbreviating them here with H and F. So we want to know the probability of getting a hawkeye and then a falcon. And so this is time ordered here. We're talking about the probability of getting this one and then getting one after it. So in order to get the probability of getting hawkeye and falcon, we're going to plug in their probabilities here. So we got the probability of getting hawkeye times the probability of getting falcon. And we can just plug and play from here. So we have the probability of getting hawkeye is 0.05. And the probability of getting falcon is 0.18. And if you multiply those, you're going to come out with a probability of 0.009. In other words, you have a 0.9% chance of first pulling out a hawkeye and then pulling out a falcon. And again, these are time ordered here. And by the way, if it hasn't been clear, the relationship between a probability and the percent chance, you're multiplying your probability times 100. So each time you're just moving the decimal place over 2 to get there. All right, so those are our different rules. We'll come back to them in a little while, but first I'm going to talk about probability distributions.